see this first? Who remembers going way back in the course?
The trap, the user permission, system permission.
But yeah, very permission. How about multi-programming? Remember the very first time we started talking about multi-programming, that's where you have multiple programs running at the same time, and we needed to protect one from the other so that one cannot hog the system. That can potentially happen as soon as there are multiple programs running in the system at the same time. Or users, processes, must be protected from one another. Another scenario is that when two processes are running, one process could potentially take up all the memory, right? And don't prevent other processes to run, right? That's also lack of protection, isn't it? And we know what resources are, right? We just talked about two, right? What was the first one? CPU time, right? That was the first example that we said. And the second one was memory, right? What else? What other resources are there?
Printers.
What?
Printers.
Printers, file system, yeah. Network bandwidth, right? That's another resource, very important resource nowadays. If there are multiple CPUs, the CPUs themselves, right? Things like that. So yeah, this was the first conceived in multiprogramming. Multiprogramming OS. If there is one program at a time, there is no point in protection, right? The way that we're defining it, right? Let's quickly contrast, although I'm going to talk about security shortly, contrast protection with security. Security is preserving the integrity of the system. This is chapter 15. We're going to look at that as well shortly. So your security can be compromised if a user that is not supposed to be in the system can get access to the system, right? They might not do anything malicious, right? But nevertheless, your security is compromised, right? Do you agree? That's different from protection. So principles of protection. First, principle of least privilege. You have seen this all along, using systems. So the idea is users, processes, given minimum right to perform a task. Just what they need to do a task, right? No more. So you're going to set up your operating system that way. So some examples here are separate accounts for each user. With just the privileges that the user needs. Right, so if a user wants to run an accounting program, right, they should not have access to admin commands, right? Of course, right? Better yet, they should not have access to any other program, right? Just that particular application. What do you think? So when you think about it on Unix, Linux, once you have an account, you have this whole lot of access, right? Isn't it? You can do a lot of things that you really don't need to. A typical user doesn't need to, right? Of course, you don't have root access usually, but other than that, you can run any command, basically, most commands. So that's that's an example. Let me just write this comment down. It is important that this principle usually does not produce a secure system. Just look at Windows, right? Like 5 years ago, every other day you would hear of a security threat that occurred and they would patch up the system, remember? Nowadays it's a lot less, isn't it? They have kind of plugged a lot of holes. And the reason for that, people think, or Microsoft thinks, one reason might be that Windows was too complex. And there was more to protect. Is that a good enough reason, do you think? That, when you compare Linux with Windows, Linux is much smaller. Sometimes when you buy a new computer, that bootstrap program, for Windows comes with Linux. there's a Linux running to bring up the system initially. This is so much smaller. The other principle under protection is need to know. Principle. At any time, a process should be able to access only those resources that it currently requires. So here's a good example that you have already seen and used before. Let's say that you have a process P. Invokes procedure A. Right? A process consists of multiple procedures, right? So P invokes procedure A at some point. The procedure is only allowed access to its own variables. If A is faulty, the damage to the rest of the process P would be minimal. Encapsulation, in short, right? So that's one of the reasons that we say don't use global variables, right? Global objects. Right? Same concept. If you use a global object, a faulty procedure can change a global variable, and that spreads throughout the program, right? Throughout the process, because other procedures can potentially look at those variables, right?
So what would you do in the case of a single fault?
It could be, in its own class, and then you declare a reference to that object. Pass by reference.
And do this with
Okay, so let's talk about protection domains. So a domain is a collection